A bit of complex for you. We'll do 31 and 32 for these guys here. Remember, you need to multiply by its conjugate, which is 1 minus 7i. Remember, the whole purpose of this is to get rid of the I value, and by multiplying it by this, it's really the difference of two squares, which ends up happening, you get 1 plus 7i minus 7i. That always happens. Those always go away. And then you get negative 49 times I squared, which is negative 1. So you end up getting positive 49 plus 1 is 50 for a denominator, and that was the goal. Our goal was to get rid of our I down there. Up in the numerator, we're just going to have to multiply that out. So we have our 2i minus our 14i squared, which is negative 1. So when we multiply that together, we get our positive 14 plus 2i over 50. But then 2 goes into all of them, so I'm going to reduce every single one of these guys. We get this as an answer. You could also write it separated like this. Either one is fine. All right, now this one's kind of special. You look at this and you're like, oh no, I can't do my conjugate. But remember, the purpose is to get rid of the I. So if I just multiply by an I on the top and the bottom, what I end up getting down here is 4 times negative 1. And that was my goal, is to get rid of the I anyhow. And in the numerator, I end up getting negative 6i. So I do get positives when I divide both sides, top and bottom, by a negative. I do reduce, so I get 3i over 2, and then that would be my answer. Because again, the whole purpose is to get rid of the I in the denominator.